This is a podcast on acids and bases, the first Webassign. So question number 1, bases tend to be slippery to the touch and they taste bitter. Question number 2, acids you might eat have a sour taste because bases are bitter. Question number 3, select all the following that are examples of basic solutions. Basic solutions. Baking soda is a basic solution. Hopefully you remember that from your grocery store lab. It turned pink. Bases turn pink with phenolphthalein. Sour Patch Kids are acids because they have citric acid in them. Sodium hydroxide, anything that ends in OH is a base. Soap is slippery to the touch. It's a base. That is hydrochloric acid, so that's not a base. Lemon juice is an acid, so it's not a base. Chocolate, if you read the notes, is very alkaline. Alkaline means basic. And acetic acid, if the word acid is in there, it's not a base. It must be an acid. The next question, which of the following of these is or are acidic substances? Well, lime juice is acidic. Soap is basic. Chocolate is basic. Acetic acid, duh, acid's an acid. Baking soda is basic. Bleach is basic. HBr is an acid. Grapefruit juice is acidic. And orange juice is acidic. Arrhenius was erroneous. Read your notes. Who taught himself to read at the age of 3? Arrhenius. Now we're going to get to the real good stuff here. Write the conjugate acid. So write the conjugate acid for each of the following bases. So if you're a conjugate acid, you came from a base. If you're a conjugate base, that means you came from an acid because they're opposite pairs. So we're trying to find the conjugate acid. So it started from a base. To go from a base to a conjugate acid, you gain an H. So in this very first one, we're starting with NH2 minus, and let's think of a number line 0, plus 1, plus 2, minus 1, minus 2. We add an H, and H's are positive. And so when you add, you're going one more positive on the number scale. So you started here, and you're adding one, so you're going to neutral. So your answer is NH3. Now let's look at the next one. It is NO3 with a minus. If we add an H, the H always goes in the front for this one. The H went there because that's where the H's were grouped. So it's HNO3. I started again at the minus, and I'm going to 0, so it's neutral. We would never write that little knot in there for neutral, but that is what it is. Now let's look at the next one. IO3. So we have IO3 with a minus. If we add an H, it's HIO3, and it's neutral because we moved from minus 1 to 0. Let's move on to write the conjugate base. So this one says we're going to write the conjugate base. So a conjugate base came from an acid, and to get from an acid to a base, we lose an H. And if you lose an H, you become one more negative. So we have HC2H3O2. Where am I getting these from? That's where I'm getting it from. This is acetate. You cannot mess with Texas. So that means you can't take away those H's. But for an acid, you take away that very first H. So you take away that first H and C2H3O2. It started out as neutral. Now we're moving 1 to the left on the number scale, so it's going to be a minus 1. And in fact, if you just looked up acetate on the pink sheet, you would see that it is a minus 1. Let's look at this next one. NH3. So NH3, if we lose an H, it's going to become NH2, and it was neutral, so it's going to become a minus 1. This last one on here is H2S. So H2S, if we lose just one H, it becomes HS, and it was neutral, and now we're going 1 over, so it's minus 1. So we just took away one H from there. Let's look at this next one, HCO3. So we have HCO3 with a 1 minus. We'll take away that H, and it becomes CO3. And we go one more over on the number scale to the left, and that's going to be a 2 minus or a minus 2, whatever works for you. So that's the answer, and you can see it there. The next one For each of the following aqueous reactions, identify the acid base, the conjugate base, and the conjugate acid. So let's review here. In an equation, if we have doodle plus dawdle makes skippity-nap plus plippity-plap, we have four lovely things. On this side can only be the acids and the bases, and on this side can only be the conjugate acids or conjugate bases. So you would never have those on the right side, and you'd never have those on the left side. They're segregated to their sides. And again, the acids are the ones that lose an H, and every acid has a conjugate base, and the bases are the ones that gain an H, and every base has a conjugate acid. So they have these opposite pairs. So let's look at this. So we have this creature here, which I have no idea what it is. So I'm going to go to this one, and I'm going to find the thing that looks like it's pair, and it is that one. So from there to there, it gained an H. So that means that that is the base. And so we write that in the base area. If that's the base, that means by default that that's the conjugate acid. So that's why that one is written there. And by default, that must be the acid. So I'm going to type it there. And then that must be the conjugate base. So you have to type the whole thing in there and get all the syntax right, or you don't get the answer correct. I know, Webassign is going to kill you, isn't it? Let's look at this next one. I see H2O. Perhaps that's not exactly what I want to do. Let's get out of that mode. Okay. So we have H2O, and its pair is H3O. So from there to there, it gained. So that must mean that's the base, and that's the conjugate acid. And is it? Yep, that's the base. That's the conjugate acid. And by default, then, that must be the acid, and that must be the conjugate base. Ching, ching! Make sure you type it in there correctly, the positives, the minuses, the stinking brackets. Let's look at this next one. It's a beauty, eh? Straight from Canada. So I'm going to look at HOCl again, and I'm going to find its match. So from there to there, it lost an H, which makes that the acid, and that makes that the conjugate base. So yes, indeed, that's the acid. That's the conjugate base. And this one should be the base. It should gain an H, and it did. I see it did. So that's the conjugate acid. So there's the base. There's the conjugate acid. Now this next one, you have to identify these parts again. It's just a little bit different format. Let's take a looky-took. So we have CN. So from CN to there, it gained an H. So that must be the base. And that must be the conjugate acid. And from here to there, it lost an H. Things that lose H's are acids because they're angry. And that means that's a conjugate base because every acid has a conjugate base. So this one, HCO3, looks like it's paired to that one. It gained, so that one's the base. That has to be the conjugate acid. And this one must lose an H, and it does, so that's the acid, and that's the conjugate base. Let's look at some more of these. HCO3 minus looks like it might be paired with this. It lost an H, so that makes that one the acid, and it is. That makes that one the conjugate base, and it is. And H2O has to be the base, so it has to gain an H, and it does. So that's the base, and that's a conjugate acid. So in this next one, what does it say? What are the conjugate acid-base pairs in the acid-base reaction above? Select all that apply. All right, so conjugate acid and conjugate base pairs can only differ by one H. And otherwise, all the other things have to be the same. So this one differs by one H, so it is a pair. This one is not, because that one has H's, that one has no H's, and that one has N's, and that one has no N's, so that one's not even close. This one differs by one H, so it's H3O and H2O. And this one, again, has an N, and that one doesn't have an N, so it doesn't even relate on there. They can only differ by one H. All the other parts must be the same, and then the positive or minus sign probably changes depending on which direction we went. So which of the following terms describes HCl in the following reaction? Let's check out HCl. So here's HCl. HCl from here to there. Lost. Things that lose are acids because they're angry. And so it's not a base because base is gain. It is an acid. Acids lose. It's not a proton acceptor. It didn't accept a proton. It donated a proton, so it's that. Question 13. What are some physical properties that historically led chemists to classify various substances, acids, or bases? I believe that they probably tasted things back then, which is not really a good idea. But acids tended to be sour and bases tended to be bitter. And I think our palates probably have a little bit difficult time discerning between those, but there is a difference. What is the conjugate base of water in the above equation? So I see H2O. H2O went from that to that. So that is the conjugate base of that. So it acted like an acid there, and there's the conjugate base. And by default, the other one must be the base and the conjugate acid. So if you get one correct, well, two correct, you usually get the other ones correct. So write the conjugate base for the following acids. Let's scroll a little more. Let's recap again. So write the conjugate base. So if we have a conjugate base, we're coming from an acid, and that means we are losing an H, and we're becoming one more positive. So NH3, lose an H, is going to become NH2 and a minus because we lost one. We went one left on the number scale. So HCO3 minus is going to become CO3 2 minus because we went one more over on that number scale. And identify the acids in the above reaction. So I'm going to look at NH3, goes to NH4, so that must be a base, which makes that the conjugate acid. So that one's kind of acting like an acid if you went in reverse because it would lose. So there's that one. And this one must be the acid, and it does. It loses an H. So that's the primary acid, and that acts like an acid if it goes in reverse. Question 17. What are the conjugate acid-base pairs in the acid-base reaction above? Select all that apply. So again, the acid-base pair has to differ by one H. It can't differ by anything else. I think I have repeating questions in here. How silly of you, must say. That one has an N in it, that one doesn't, so it can't be the answer. This one again has an N, that one doesn't, it can't be the answer. These ones do differ by one H, and that one differs by one H. So those two are the answer. What is the conjugate base of HClO3 in the above equation? So we have HClO3. It looks like it loses an H, so that means that's the acid and that's the conjugate base. And there we go. I hope this was helpful for you, and we will check in again later.